All right, going over the answers to the OpenNote quiz here. First part of this is to identify the type of reaction. Okay, so I've done that in this column already. So this first one's single replacement because I have an element and an ionic compound, metal and a polyatomic here. Second one, combustion, because I have a carbon compound and oxygen. 3, double replacement, because I have a metal, nonmetal, and metal and polyatomic, so 2 ionic compounds. Synthesis, because I have 2 elements. Decomposition, because I have 1 reactant. Oh, one thing to know about synthesis. Element, but metal and nonmetal more specifically for our class. Here I have a metal and ionic compound, that's single replacement. Here I have combustion, carbon compound, and oxygen. Double replacement is element and compound. Element and compound. Oh, what am I saying? Sorry, 2 compounds. Metal and polyatomic. Metal and polyatomic here. Decomposition, 1 reactant, and synthesis, metal and non-metal. Yeah, I'll just leave that. Technically, that should be an 8, but I'm going to fix that really quick, and then that'll be fixed on yours. Okay, so what I have here now is I'm going to do the combustion reactions first because I think the products for those are the easiest. If I can identify as combustion, I know it's going to be, oh, what is that? CO2 and H2O are my products. Okay, so that's for number 2 and number 7. And then balancing I'll come back and do at the end once I write products for all of these. So combustion, CO2 and H2O. Next I'm going to do synthesis. So in synthesis what I have to do is figure out my charges of these elements and then put them together. So Li, what is that? And S, what is that? Well, the good news is based off of my periodic table, I know that Li is a 1. That 1 will go to the S, and the S is a 2, which will go to the Li. So we get Li, and then writing subscripts here, always a pain. So the 2 from the S is going to end up down here on Li. The 1 goes down there. Okay, come back and balance later. Other synthesis, I got Na and O, which is actually a very similar problem. I'm actually going to get Na, which is a +1, with O, which is a -2. So I'm going to end up with Na2O again here. Ooh, and I want my balancing station. Okay. Next, I'm going to have decomposition. I think that's the easiest one. So remember, for decomp, what I do is I take all the elements and I split it up. So I got Fe plus I plus O. And then what I have to decide are any of these sneaky 7s. And iron is not, but iodine and oxygen are both sneaky 7s. Okay. So my other decomposition, I got Na, N, and O. So I'm just copy and paste from here. It'll be a little bit easier. So we got Na, N, and O. And actually nitrogen and oxygen are both sneaky 7s as well. So they need 2s on them when we do that. Again, I'm coming back to balance at the end because that's a separate skill. Next, we got single replacement. So realizing that cobalt and magnesium are going to switch spots. So cobalt is going here. Mg is going here. Now, based off of this, this is actually what I'm going to end up with as my final product. But it's because Mg is a +2 and sulfate, SO4, is a -2. So the like charges cancel, giving me MgSO4. Okay. Other single replacement right here. So H and Na are going to switch spots. H is a sneaky 7, so when it's by itself, it needs a 2. Na is a 1 when it crisscrosses with CO3, which is a 2. So the 2 from the CO3 is going to go to the Na, so I get Na2CO3. Okay, so that's single replacement. And then my last 2 are double replacement. So here V and Mg are going to switch spots. You could write it either way. So both, I'll show you. So Mg is going with Br, and V is going with NO3. Now Mg is a 2, and Br is a 1. So Mg is a 2, Br is a 1. So when I crisscross, I get MgBr2. And V, in this case, can be a 3 or a 5 based on our periodic table. So because Br is a 3 right here, I know that 3 came from the V when it crisscrossed. So I need NO3, 3 right there. You could write this, or I'm gonna the order doesn't matter, or this one plus Mg. And so it doesn't matter, right? Both those examples are acceptable. The order you write them in doesn't really matter. And then my second one here, Mg and copper are switching spots. So Cu is switching and Mg is switching. Now one thing to note is I already know this, nitrate is a, hold on really quick here. Nitrate is a -1, magnesium's a 2, so the 2 from magnesium is going there. Nitrate, the 1 is going to go to magnesium. In this case, copper is a 1, and ClO3 is also a 1, so both those cancel. Okay, so now I'm just going to go through and balance. Balancing is an old skill, but you know, if you're struggling to balance still, let me know, and we can revisit that together. Of course, as always, remember you can set up a time to meet with me digitally. So what I got here now is I got 2 COs, 3 SO4s. I could choose either of those to go with. Say I just start with COs. And I need 3 SO4s, so I need a 3 there. 3 SO4s, that gives me 3 Mgs. Need 3 Mgs, and then that would be a 1. Remember, you can leave them blank if you want. So combustion, I start with carbon, 5 Cs. So 5 Cs, 12 H's, so I need 6 times 2. Reason I do O last because I have 2 spots over here, so I have 10 plus 6 O's, giving me a total of 16, so I need an 8 on that side. Here, I can start anywhere. Notice my NO3s, I have 2 of them here, and on that side I have 3. So I know I'm going to need 6 of those. Okay, so that gives me 6 of each of those. Now I got 2 V's, so over here I need 2 V's. It gives me 6 BRs. Need a 3 there. It gives me 3 Mgs, 3 Mgs, and now I'm balanced. Okay, here I got 2 O's, so I got to put a 2 here. It gives me 4 NAs. So this is going to be a really tall 4 Na. Now this one might be a hard one to balance for you. So here's the key. If I have an odd number on this side and an even number on this side, I'm going to have to double the odd to make it even. So what I mean is I have 1 iron, 1 iron. They're both odd, that's fine. Here I have 3 I's and 2 I's. See how one's even, one's odd? I'm going to have to double the odd one to make it even. Same thing with O's. I got 9 and 2. So if I double this, it's going to be 2 irons, so I need a 2 there. It's going to be 3 I's times 2 to give me 6. So on this side I need 3. 3 times 3 is 9, times 2 is 18. So on this side I'm going to need 9 times 2 to give me 18 oxygens. Notice 2, 2, 3, and 9 can't reduce all those by the same number. Here to balance, the only thing I need is a 2 there. Otherwise I got 2 H's, 2 H's, 1 carbonate, 1 carbonate. Remember, I had taught you guys, if it's helpful, circle a polyatomic ion or box it so you can see it's the same on both sides. So like ClO3 down here, we'll come back to that one, and ClO3 right here, or NO3 right here, and NO3 right here. It's exactly the same, meaning that 3 is part of it. So 3 carbons is going to be 3 carbons, 8 hydrogens, so I need a 4 there. Gives me a total of 6 plus 4 oxygens for a 5 right here. 1 Mg, 1 Mg, 2 ClO3s, only 1, so I got to put a 2 here. Gives me 2 coppers, so I need a 2 here. That gives me 2 NO3s, 2 NO3s, and I'm balanced. And this one's similar to that Fe one. I have an odd number of oxygens and an even number on this side, so I got a double. Gives me 2 NAs, 2 NAs, 2 Ns, 2 Ns, so we're good, and 6 oxygens, so I need a 3 there. Again, you could put a 1 in all these blanks if you want to, you don't have to. So here I got 2 LIs, 1 Li, and S and S. Okay, so I'm going to fix my S's first. That's what's going to make it easiest. 8 times 2 gives me 16 lithiums, so I'm going to need a 16 here. And then 1 S8. 1s8. Okay? The last one's already finished, and I'm just going to talk through them. So when the reactants have more energy than products, that means I gained energy because I'm going to end up with, take that back. Reactants are what you start with. They have more energy. That means reactants, I lost energy, which is, misread that, exothermic. Reactants starting with more energy than my products. It's exothermic. I lost energy. AQ means aqueous, which means it's a solid dissolved in water. So in this reaction, the number of molecules is actually equal to the coefficient. Okay? So it's 225, 2 octanes, 25 oxygens, 16, and 18. That's just understanding what a reaction says. We balance chemical reactions with like the 225, 16, and 18 here because the law of conservation of mass states that matter cannot be created or destroyed, meaning we need to have an equal number or amount of atoms on each side for each element. And an example of a chemical reaction would be your car combusting gasoline in the presence of oxygen to produce carbon dioxide and water, but it also releases a tremendous amount of energy, which is then used to move your car forward. Let me know if you have questions, guys. Bye.